Number 25 says, let f be the function defined by f of x equals the square root of x. Using the line tangent to the graph of f at x equals 9, what is the approximation of f of 9.3 equals the square root of 9.3? In other words, we're going to use a little bit of calculus to estimate the value of the square root of 9.3. Also notice there are no answer choices for this problem. A few of the questions on the actual CLEP test will not give you multiple choices. You'll have to solve it and bubble in whatever numerical answer you get. So first, before we start going through the problem, I'd just like to cover conceptually what it is we're doing here. So if we can visualize the graph of the square root of x, which is 1/2 of a parabola that's been turned over on its side, we are going to use a line tangent to this graph at x equals 9. This line might look something like this to estimate the value of f of 9.3, which would be very close to it. Now, as you can see on the graph, the points right around x equals 9 on that tangent line, if we're looking, somewhere around here, are going to be very close to the points that are on that square root graph, which makes this technique very useful. We won't have to know any special algorithms for calculating square roots or anything like that. We just need to know how to find the equation of this tangent line and then substitute in 9.3 into that and use that as our approximation. We wouldn't want to use this line for any points that are too far away from x equals 9. Like this, whatever equation we get for that tangent line would not be particularly useful for estimating, say, the square root of 12 million or anything like that, because those values are just too far away, and the gap between the tangent line and the curve square root of x gets wider and wider as we move x towards infinity. But right around x equals 9, the points are pretty close, so we can go ahead and use it. To come up with the equation for that line, we are going to use point-slope form of a linear equation. The point-slope form of a linear equation is y minus y1 equals m times x minus x1. We will need the point of tangency, where that line is tangent to the curve, and we'll also need the slope of that tangent line. Now the point should be pretty easy to find because it is the same as the point on the square root of x. And since we're interested in x equals 9, the square root of 9 is 3. So the y coordinate of that point is 3. The point that we're going to use in that point slope form then is 9, 3. Next, we need to find the slope of that tangent line. And to do that, we're going to need to differentiate f of x. F prime, or the derivative of f, represents a function that gives you the slope of f at any x value. So if we rewrite f of x as x to the 1/2 power, we can use the power rule to find f prime x, or the derivative of f of x, which would be 1/2 x to the negative 1/2, or if we want to rewrite it using the square root, would be 1/2 times the square root of x. So if I need the slope of the curve, which will be the same as the slope of that tangent line at x equals 9, I can simply plug in 9 into that equation and get 1/2 times 3, which is 1/6. So the slope of that tangent line is 1/6. Now we have an equation for that tangent line. Y minus 3 equals 1/6 times x minus 9. Now that we have that equation, we can use it to approximate f of 9.3 by simply plugging in 9.3 into x and solving for y. So let's go ahead and do that. Y minus 3 equals 1/6 times 9.3 minus 9. 9.3 minus 9 is 0.3, And now we need to multiply that by 1/6. Here we've got a terminating decimal times a fraction which does not have a terminating decimal. So we're really going to have to convert that to a fraction to get the exact value. 3/10 is equal to, well, I guess the way you read it is what it is, 3/10. So y minus 3 equals 1/6 times 3/10, which is 3/60. Or if we reduce that, 1/20. I'm going to rewrite this equation so it looks a little nicer. And then I'm going to add 3 to both sides. So I have y equals 1/20 plus 3, which would be the same as 1/20 plus 60/20. So y would be 61/20. Now, depending on how the answer sheet is set up, if you're lucky, you'll be able to just go ahead and write out this fraction. But if you have to convert it to a decimal, then we're going to have to do a little long division. So if we need the decimal, we need to divide 61 by 20. 20 goes into 61 3 times. 3 times 20 is 60. Subtract, put a little decimal there, bring down the 0. 20 does not go into 10, so we'll have 3.0. Then we'll bring down another 0 to get 100, and 20 goes into 100 5 times. So I'm not honestly really sure whether you're going to have to bubble in the fractional answer or the decimal answer, but either way, your answer is going to be either 61/20 or 3.05.